I usually like to ask this. I know a few of you guys have some mobile shops, but who's never done anything with Android besides play Flappy Birds? Okay. By show of hands, did anybody actually mess with glass or Wear at all at this point? Okay. A lot or a little bit?
A little bit.
Okay. So yeah, the presentation assumes that you have a little bit of Android knowledge. I'll run through kind of like the TLDR on Android for you guys, just to make sure everybody's on the same page. Really today we're going to talk about what's different with these platforms as opposed to, I guess, spreading fear and false information. That's weird. It's showing up here with 4 things and there's 2 up there. Anyways, that's me. Yeah, that's weird. It's showing up just fine. Anyways, I don't care. It's PowerPoint.
Just use more.
Yeah, so wearable devices, there's definitely a lot of buzz, a lot of hype, a lot of, let's face it, marketing jargon out there, the sky's falling, the world's ending. In reality, these devices do introduce some new things to consider, but fortunately there's a lot of things that you may already know about, for example, mobile devices, interacting with, say, embedded devices, Internet of Things type things. So, yeah, not everything is new. So what kind of applications are we seeing for different wearables these days? So one thing that's really interesting is uses in the medical field. So if you go online and look for like funding Google Glass startup, you'll see a ton of companies that are getting funded to do things in the operating room, for example, or dentists that maybe the whole goal is to get them timely information without say whipping out a smartphone inside an OR. Of course, if you can manipulate that information, then that's pretty interesting. Surgery might end up like, say, how I put together like a new piece of furniture. There's like extra parts at the end. So, also seeing different wallet applications. So this one's actually open source. This one is a Bitcoin wallet. We'll look at it a little bit later because there's some things they did architecturally right, in my opinion, that I think a lot of the apps I've looked at thus far, especially for Android Wear, aren't doing. Just totally oversharing information with different devices that may be better off restricted to like a handheld. But in any event, this is definitely an interesting application. We also have fart applications because, let's face it, we need those. So this one's pretty advanced. I mean, you can have a long fart, short fart, whatever. But yeah, the crazy thing is somebody's probably going to make millions off this, right? This one's actually creepy. So Google filed some patents for eye tracking. So this wonderful device right here actually has a little eye gesture detector right here. So it can detect like winks, it can detect which direction the eye is moving in. So right now you have a couple classes of ads. You have impressions. So basically, if anybody's familiar with Google AdWords, LinkedIn, I mean, most advertising these days, you can have like impressions where basically, you get charged based on how many times that ad is displayed, which ends up being a little bit cheaper. You pay more if somebody actually clicks through the ad to your, actual website. So Google's essentially, because let's face it, like it's a cool device, but Google wants to sell you ads, and if they can shove ads right in your face, they're going to do it. So it kind of adds another category. So instead of just saying like you clicked, it's basically, I actually looked at the ad. And if you look at the ad, so you can imagine there's definitely some creepy implications for what advertisers can really find out about you at that point. I mean, I can tell you, I see a blinky ad and I'm like, yeah, I don't care, but something might catch my eye that, maybe is a little revealing about me. So just something to consider with the next wave of advertisements, I guess, where they're going with that. So this one is interesting. So somebody got their case thrown out a few months back. So she was driving with glass on, and they threw it out basically saying there wasn't enough evidence to prove that she was actually using it. So if anybody's done any, probably not, but looking at like what glass actually stores from a forensic perspective, you can tell like when the device was turned on. It also tells you like battery drain when it hits certain amounts going down and stuff. So you can actually use like a bunch of different things that glass actually stores about you to figure out maybe if that device is being used at that time. If battery was draining faster over a 5-minute period as well that tells you maybe engage with the device. So interesting things. I mean, maybe I shouldn't have the best thing. I've actually driven with it a couple times, but it gives me a headache, to be honest. Like if I wear these things for more than like 20 minutes, I want to bang my head against the wall. Who thinks these actually make me look cool, by the way? Anybody? Did I get any extra friends today? No? I mean, I've had these for a year and a half, and I've used them. I just feel like a total D-bagger, to be honest. It's like, the elderly and little kids think you're the coolest person in the world, and everybody else thinks you're an asshole, pretty much. So I try not to use them much. I mean, at some point they'll probably get the form factor right, it'll be thinner, sexier, but for now, I mean, it just makes you look like a jerk. So, anyways, let's jump into the actual technical stuff here. So, both Wear and Glass are Android at the core. So they both do add some interesting twists and turns in terms of how you can communicate between devices, and also different ways you can consume data externally. Security model, so if anyone's not familiar with how Android does things, take what you know about how Linux enforces permissions, discretionary, mandatory. So for example, one user shouldn't be able to access the data for another user's applications. There's some sandboxing there for that. And that stuff is pretty much the same how it works. What is different, though, we'll talk about, is how there's different communication channels between the devices now, and there's totally different, not different, but there's some different factors there, how security enforcement is actually done. So let's take a look at just what it looks like now. So this is probably the ugliest thing that I could have made out of OmniGraffle, so deal with it. But basically here you have your phone or your tablet, which essentially is becoming kind of like the hub for all of your, at least Android wearables. So here's Glass. So Glass has Wi-Fi, it has Bluetooth. The current Android Wear devices are just Bluetooth only, but they all do support Bluetooth Low Energy. None of them have NFC at this point, so if you wanted to actually do payments via NFC, you can't do it. You still have to whip out your phone to do that. But in any event, Glass has a browser. Glass can communicate with the web directly. We'll talk about the Mirror API, which is another thing that gets bolted on top. And you also can communicate through the handheld as well. So both have their own companion apps. As for Wear, you're essentially just basically communicating through these APIs. So it's all over Bluetooth. You're not doing straight sockets out to the web at this point. You're really basically using your handheld for everything. So if you don't have a phone, then Wear is mostly worthless. So both do have companion applications. We can look at the code depending on where we go with time, but essentially all communications goes through them. For Glass, so you'll have the companion app on here called the My Glass application, and what that application allows you to do is basically authorize glassware. So some applications that get installed on Glass actually install like an APK. Some actually don't. They just basically do OAuth, the little OAuth dance, and then basically gives authorization to that device. As for Android Wear, so your applications are actually installed through Google Play services on the phone. So just to give you an example of like what it will look like in Android Studio these days, so let's just create a new project. Let me see, things. So basically what you do at this point, you have a little checklist of the different form factors you can work with. So has anybody worked with a Messer TV at all? No? I haven't yet. It's on the list. But anyways, the one that's really key here is if you're going to build a Wear app with it. So you just hit next, just go with defaults here, and finish. Wait for it. At some point it's gonna, there we go. So what you can see is that you have, your project, and then you have these different applications underneath it. So this is obviously the mobile one, and this is Wear. So when you actually build that and push it up to like Google Play, there's actually an APK sort of like inside an APK. So once you would install that application, if the handheld detected that there was actually a wearable device connected as well, then it would go ahead and push that APK out, and it will push it over that channel that we communicate over. Okay. All right. So let's talk about Glass a little bit. So interaction with Glass is actually a lot more limited in comparison to other things. So you don't have a keyboard, for example. Pretty much what you're working with, and I mean, you do look a little ridiculous, right? So you have head gestures where you turn it back on. So am I winking at you or am I taking your picture right now? Well, actually, it's off, so I look like a total jerk. But anyways, yeah, so that's actually one of the gestures. It's like a long wink. So you have a handful of those. You have, flip your head back. You have, flip your head down. And then you also have, so that's the nut. Basically, this is to turn on. You can turn it off doing that. And then you also have, which is in the newest release, XE22, notification sync. So you can actually get notifications pushed basically directly here. And actually it's pretty cool because when you do turn it on, or when you turn notification sync on, you'll hear bing, notification comes in, and you just turn your eye. And because this thing's always kind of like watching you, it'll just turn the display on so you can actually see it at that point. Additionally, I mean, optical recognition, so, scanning in like QR codes, stuff like that is pretty big because, for example, like, if you want to activate Wi-Fi in here, they want you to do it basically by scanning like a QR code. So obviously QR codes can contain malicious things. There's a browser on here, etc. So you can potentially have some fun with that. But yeah, this guy here, that's like total fail, like 100% fail because he has glass in his face. So there's a handful of different kind of applications. So immersions are the one that would be most familiar, coming from an Android, anything. So basically an immersion is like a full-blown application that you can interact with. I mean, you have web views, you have access to all the privileged APIs. It's pretty much like a standard application. Obviously, you don't have a keyboard. So this one here, you're basically running from boulders that are trying to kill you. So if that's your kind of thing, go down with that, I guess. Additionally, Glass has cards. So there's two types. There's static and there's live cards. So static is really generic, so it doesn't really let you do much aside from see information. Live cards give you access to other things, and you can also basically switch out what kind of views you have. So you have a little bit more attack surface there as opposed to a live card. One thing that's good though is the applications that created them are the ones that own the card. So basically you can actually share out with other applications, which I guess depending on what you're actually showing the user, you kind of have to use discretion with which application you would share that with. But at the very least, it is protected at that point to the application that created it. So let's talk about the Mirror API. This is one of the really interesting things about Glass. So the Mirror API is just a RESTful API, but you actually build on top of your own web application. So here's an example of an implementation of the Mirror API. So ripped this off the web and just basically did a little bit of tweaking to it. So this is a regular Spring application. So it's an MVC application, you have controllers, etc. Nothing really different there, except just taking a look at the Mirror client, for example. Here's all the different things that you're actually able to do. So for example, you can insert things in the timeline, you can list things out from the timeline. You can also have attachments within the timeline. So, if there was a way to maybe attack the web service, you could potentially control that person's glass and you could potentially pull information off that. Because in the end, you're pretty much using a web application to basically proxy those calls out for you. So, as you can see, you're exposing it all via, sorry, someone says it? No? Go once, go twice. So, standard controller, right? So here's, a call you can make, and you can see down here is pretty much, this is where it's doing the interactive timeline service and all that good stuff. So you have Glass here, you have web app, then you have Mirror API, that's Google. So, that web application is what's in between, basically. So I don't need to re-explain the web to you guys, but it's something to definitely consider because it's just another channel basically for attack. So here's kind of the flow of how it works. So in the My Glass application, you would pick an application that you want to use, you say turn it on, and then you basically get sent over to web app, little front end, let you punch in your creds, you'll do the OAuth dance on the back end. And then you can begin to interact, send data back and forth to that device. So the Mirror API is definitely one of the things with Glass that's very different than straight Android, basically. Additionally, one thing to consider is, so if you say, trying to pick something, maybe you want to delete a status update or something like that, or maybe, some kind of data came back from your bank and you're like, okay, I want to delete that, so on and so forth. But anyways, pick any type of data that you would get here, and maybe you delete it here, you say, okay, just get rid of that. Glass won't actually, so if you're, putting that in your own type of data, whether it's a database, etc., Glass won't sync that for you at that point. So you actually have to, handle that event, and basically, if that person wants to get rid of that data, you'd actually have to make sure you did that on your backend web application. So it's not doing it automatically. So, if it's, privacy sensitive, be conscious of that, because your users are going to pretty much hate you if you don't get rid of that data for them. All right, taking this off my face again. Let's talk about Android Wear now. So Android Wear is very scaled down in comparison, but at the same time, it's probably the most different in my opinion, just because of the way it works. So for starters, as I mentioned, you don't have any Wi-Fi, which means some of the cool stuff you can do, like Wi-Fi Direct. So Android lets you do like peer-to-peer wireless stuff. That's off the table. NFC is not there, so obviously you can't do payments. You can't like share your contacts, which from a watch, to be honest, like that's appealing. As opposed to having to take this out. I mean, the whole goal of the watch is so you don't take your phone out as much. I mean, that's the whole goal, was to make things glanceable. What other buzzwords can we throw? They're contextually aware, etc. But that's really the goal. So you basically take this out of your pocket less often. At the same time, Microsoft just released a couple weeks ago. It was like an R&D project, but it was basically to make it easier to write on here. So it's another kind of weird thing. I mean, if I was just sitting here doing this, like, would you think like I was like scratching myself? I had like fleas or something? But maybe they'll give us stylus next, because that's what we need, right? Because we're moving backwards again. Additionally, web views aren't there. So if you have PhoneGap code, if you have existing JavaScript, HTML code, get rid of that, because you're basically going to be building your views out and stuff like that natively. So Android Wear exposes a few new APIs of its own. These are the three big ones. So everything interacts with Google Play services. It's kind of distracting for a minute. So yeah, as we'll show a couple examples of. So Google Play services does a bit of the enforcement and also tries to sandbox, help you basically know how to do that across those boundaries for like remote procedure calls. So one of the main things in a Wear application is the wearable listener service. So just for anybody that's not as Android-ish, so Android has services. So think of like, if like a service on your operating system that just runs in the background, that's exactly kind of how an Android service works too. It's intended for like long-running operations. So the wearable listener service extends the standard service class, and it adds some new things of its own. We can actually take a look at one here. There we go. So this is actually the actual code itself from the framework. But let's take a look at something that's not going to give you a headache just yet. So let's take a look at the Bitcoin model we were just talking about. So you'll see, this service extends the wearable listener service. So you have a couple new things. In the onCreate, you're generally setting up, a Google API client that's for Google Play services type stuff. But the things that are interesting from a Wear perspective are on message received, and if there were to be, so other applications might have like on data changed, and then there's also for the node network, there's different things like, for example, like on peer connected, on peer disconnected. And that's just basically to let you make decisions based on which devices are actually connected at that time. But that's the basic gist. So what ends up happening is you'll receive a message, and then you can pretty much like parse, what's in it to basically determine what's going to happen. So it is the primary place to receive remote procedure type calls. And there's a check, basically right here. That's actually the actual wearable listening service itself. That's going to be hard to see now, isn't it? Make that full screen. All right, can you actually see that in back? Okay. Yeah, so there's just a couple simple checks basically. So binder, if anyone's not familiar, just think of basically a low-level way to basically identify you. That's probably the worst yet highest level description I can give. But essentially, that's where a lot of like access control decisions are made and everything like that. It goes through the binder stuff. And the other thing that they looked at there is basically, was that actually signed by Google? So they checked those couple different things to basically make sure that Google Play Services is the only thing that's actually shuttling that data across devices. So your application essentially, so I do something here, that'll go through Google Play Services, the companion app, sends it over the Bluetooth channel, and then just basically the same thing happens all the way up over there. So Google Play Services is essentially what should be communicating with that. Now, it is sending like your package name, all that good stuff across. So there's some verification, and basically what's being done there is basically making sure that like one application can only talk to the same application on the other side, at least through those APIs, which is actually a good thing from a security perspective. It's a great thing. So the Node API, this is essentially what's being used to detect like what's connected, which device you may want to. So you can have more than one device on your little wearable network. So if you look at some of the stuff that's in even some of their comments, like descriptions in some of the source code, it's like wearables can be phones, tablets, glasses, watches, and then they're like sweaters and backpacks. Like so, but they're all like smart shirts. Has anybody seen any of like the fitness shirts that basically there's like sensors all over the place? So if you're that kind of person, you can have more data about yourself than you ever want. But the Node API lets you either target like a single device on that network and lets you target multiple devices. So one thing, by the way, is Glass is slowly getting the wear treatment. So as of so we're on XE22 right now. As of 21.3, this popped up. There we go. So it's actually My Glass Wear. And if you start drilling down into so if you start drilling into it, you'll see that all the different Wear APIs are actually all there. Yeah, I gotta dig for it. So let me just move on. But anyways, so Wear is getting basically, so you can get notifications now, but all the APIs are there to basically do all the other interactions. So they mentioned at a Google I/O that obviously Lollipop was their way to slowly get the platform to kind of come together. But at some point, I bet in the next couple of releases that you'll have full-on support because the APIs and everything in the library is already there. So the message API, so the message API basically you're just sending like smaller kind of fire and forget type of messages. So this kind of illustrates kind of the workflow from that. So you're coming from one app, you're going all the way down, and basically everything goes over Bluetooth, and it just you have your security checks, verification up the stack, and then your data magically makes it to the application that it's supposed to. So one thing that's different about the Node API in comparison to the message and data APIs, Node events basically get sent everywhere to all apps. And that's just basically for, because you're not actually sending any data over that, it's just basically like, disconnected, connected type stuff. So all applications may actually be interested in that. Really no harm done there. Whereas obviously when you start sending sensitive stuff around, you want some of that inherent protection there. So that's a good thing. Data API is very similar. So persistence is kind of up to you how you want to do it at the other end. So you can store stuff in SQLite database. You can still store like flat XML files, which is basically shared preferences. So a lot of applications store a lot of stuff in like plain text XML files. So you can do whatever you want with that data when you receive it at the other end for persistence. One thing to also think about too is, so at the level that you may want to consider, basically before you send the data, depending on what you're really sending, you might want to encrypt data or do something with it before it actually passes through the other device, just to minimize any chance that any other applications might be able to receive any of that stuff at the binder level, especially if you've like rooted your device. Then you could potentially have some issues there because security model breaks down quite a bit at that point. Notifications. So notifications are still, have some restrictions. But notifications, you can also pass more complex information across. So you can pass, full-on intents. So does anybody remember, if you're not familiar with intents, basically that's the messaging kind of component for how Android works. So you can send data, from one app to another. You can set stuff like, there's data, there's like actions, categories, there's all sorts of stuff you can target, sending to like a specific class as well. So you can, basically package that stuff up inside of your notifications. Usually you don't have a ton of user control, but there could be edge cases where that actually kind of lets you break out of, working with the same application. So this is kind of the same as it works on Android normally, but we're just really just adding a different layer to it. So yeah, I lost my train of thought for a second. So in a wearable world, you generally don't want to, go through 9 steps to like confirm, 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 confirm. You want things really fast. And obviously that user experience, has potential security implications as well. So I don't know if you guys remember, it was like, maybe 3 years ago, maybe 4 years ago, something like that. This is like, I guess the best plugin kind of, so there was a Skype bug, it was an iOS thing. And basically if you used like, the Skype, calling back, and you needed like iframe to get the phone number, it would launch the Skype application, make a call for you, no interaction at that point. So they obviously fixed that and they changed it to where it would just basically populate the Skype app with that phone number, and then you'd actually have to explicitly hit call. So that example, you'll probably see a lot of that kind of stuff on here, where you omit a step or two basically. You just want to send a voice note or something like that. So other applications, so there's the where to listen to service, which is the central point where basically stuff gets shuttled between devices. But you still have broadcast receivers, you still have services, you still have content providers, and obviously activities are still there. So you have potential ways to indirectly attack the applications, or at least have so if you're connected via Wear, the handheld is the one that's actually making all the calls out to the web, right? So this is the one that's actually calling the APIs. So if you can basically tell this thing to do something, it's going to do it. So here's the confused deputy kind of scenario. And this plays out pretty much here. So in this example, here's your bad guy app. Your bad guy app tells this application, which has access to sensitive data in the database, and it has privileged APIs, and maybe this one has like no permission, right? So you can expose your components in Android a couple different ways. So here we go. So here's an example. So just to kind of show you what it looks like. So Android lets you expose a component in 2 different ways. One is you explicitly say export it, true, that's a no-brainer. The other scenario is you have intent filters. So we talked about intents is basically the messaging component, how you interact between components and applications. And you can set filters. So if you've ever used an Android app or device, and maybe you open something and it's like, hey, which application do you want to use for that, right? Has anybody ever seen that? So that's actually basically the intent resolution process at work. So there's a couple different pieces of criteria. There's actions, there's categories, potentially the data itself, they can make decisions on it. So it uses all these different things. So the problem is that once you introduce an intent filter, well then that's accessible. So you actually have to go in there and say like, don't do it. So basically at that point, so say you have a broadcast receiver that just basically receives a command to do something, and then it actually does it. So there's really no back and forth at that point. It just basically you tell that component to do something, and whatever's in that is going to happen. So if that's, for example, something that triggers maybe a message being sent to the handheld, or maybe an action or something that should actually do at the other end, maybe update profile, send an SMS, etc. You can attack that basically. So in the regular scenario, you have, let me make that bigger. You have just a handheld itself, and you have that, obviously vector there. But then you basically have the scenario where you also have, I guess just another essentially layer of abstraction at that point is that same scenario can play out here. And depending on, what types of things you can do to update the handheld, you can potentially attack that. So it's just another kind of layer of indirection. But essentially, I guess the takeaway from that is that if you're exposing similar capabilities on the wearable as you are maybe on the handheld, you should basically follow that same level of protection on both sides. You shouldn't make one lighter and one more restricted, basically, because you just open yourself up to another layer of attack. So talk about compartmentalizing stuff. So this ugly thing again. So we just talked about basically, so the wearable is making all the API calls for you. It's still a little privileged stuff with remote services. So do you think you need credentials on here? Yes? No? Okay, you probably don't. You don't need API keys. You don't need a lot of that stuff. I mean, if you're actually making those calls, great. But if you're just basically using the handheld, we'll keep that stuff there. It's just, good architecture, restricting where things go, separating out, whose duty is what. And it's just a good practice, basically. So you don't need, for example, like take like a Bitcoin wallet, right? Like you don't need to distribute the private keys here because, essentially that stuff's all being done there. So you can tell it like, okay, do a transaction, but in the end, you're still doing all the heavy decisions on the wearable, on the handheld itself. So keep that stuff where it belongs. Yeah, so actually I just talked through that, and I forgot I had the slide in there for that. So here's an example of that basically. So they just basically send the Bitcoin address, the balance, but obviously, is anybody familiar with Bitcoin? Does anybody dabble with like Bitcoin a bit? Okay, so obviously you still need a private key to do your transactions, and additionally this app actually uses like NFC as well, but that's all done on the actual handheld itself. So really the takeaway from that again is just basically send as little as you need to basically make some decisions here, but do the heavy lifting on a handheld at this point. So here's a really generic example just to kind of illustrate the point. So imagine you're, take secure containers, take, any other things that encrypt data, and think about, how do you pass around that key material? Generate in one place, you obviously need to decrypt it elsewhere. Definitely consideration. So if you're working in like a corporate environment, you're using, good, you have containers, you're happy about that. Well, now obviously you need to replicate that behavior on the wearable. So not saying it's impossible, like don't get me wrong, it's totally not, but out of the gate, you definitely have to consider, there's definitely some design considerations there. Also talking about stuff like, do you encrypt stuff before you pass it over the wearable network? Do you encrypt it where it gets to where it's eventually going to be persisted? Those are definitely considerations. There are other reasons to maybe encrypt stuff before you send it over. Maybe to prevent unwanted caching, for example. So like the wearable network goes down. There's potential, whether it spits out errors, exceptions that may be sent around. There's just a lot of different reasons to do it. But in any event, encryption is also something you have to think about. How's that going to fit your wearable world, where this data, instead of just being in one place now, you may potentially want it on multiple devices. So just a consideration. It's not the end of the world. I'm actually getting close on time. So moving forward, I mean, there's going to be a lot of FUD. So, there's just, just the nature of this industry, right? So it's like, here's an opportunity to make a ton of money, and then, the cyber experts start coming out of the shadows and talking about things that may not make sense. Just kind of take everything, I guess, coming out these days with a grain of salt, because there's a lot of FUD out there. I read something the other day, and it was like, wearables are going to be the next major security, I'm just like, yeah, there's issues, but it's not the end of the world. There's a lot of stuff, honestly, that we've already, iOS, Apple has their watch coming out pretty soon, which I'll actually use because I'm an iOS user and Wear is completely worthless to me. So, yeah, I think it's going to get interesting. I mean, there's definitely a lot of compelling use cases. Unfortunately, I don't think calculator apps are that use case, that killer app. Somebody asked me that last week, what's the killer app at this point? I'm like, I don't know, farts, to be honest. I mean, yeah, it's, does anybody actually have an Android Wear that they use like on a day-to-day basis? David, go. What's your take? Does it change your life yet? Mm-hmm. Yeah, I mean, you're not going to do a lot of work on these devices, to be honest. So with that said, I'm exactly at the end of my time here. So any questions? I know that was fairly mid. So do you guys want any more? Yeah. Any changes? So there's the smart unlock. I haven't gotten to mess with that. Has anybody messed? Yeah. Has anybody actually seen the smart unlock? How it works yet? Basically, you're like within distance of your, and you can unlock. Now, I don't know what the actual additional steps are at that point. That I'm not sure. I haven't gotten to peek at it. They haven't released the code yet. Because Glass, we've reversed most of the stuff on there, but they've really just released the kernel code at this point. So if you want the framework code, you have to rip it apart yourself. So yeah, there's just you think about okay, today we have handhelds, we have Glass, but now we're also adding TV, auto. And that smart unlock type feature is also being used basically. So you get into your car and it's like, okay, it'll just unlock my device for me. Cool. Or to unlock, your car's Android stuff. So these devices are definitely part of a much bigger ecosystem. I didn't want to use Internet of Things because I hate throwing around buzzwords because I think it makes me sound like a douchebag. But yeah, there's definitely a lot of compelling use cases to be able to, automate your home, automate your life. So. Yeah, it's really early. Wear seems like it was very rushed, to be perfectly honest. So, normal Google style, they slowly just start rolling more features into it. Gmail was beta for almost a decade or something like that. So, yeah, it's getting interesting. Google Fit is another thing. So Apple has, Health Kit. They have Fit basically, so you can track your calories, your exercise, etc. Yeah, they haven't totally released everything for Wear yet, but that's one I can see. Fitness apps there's a great use case for that. So, any other questions? Yes.
For your Google Wear, you activate pair with your handheld, right?
Yes. So it's done over Bluetooth, basically. Yeah. So
can you pair it with your phone and your tablet at the same time?
I think we'll disconnect you actually.
You can only pair with one.
Yeah, when it comes to, I believe, so I haven't tried to do the phone and tablet at the same time yet. It's a good question. I think it's going to disconnect you, but maybe not. I don't know. I'm not going to lie. Yes.
Can you go back to the slide before the FUD kitten?
Yeah.
So what's the answer to that question?
Yeah, it's just, I guess it really depends on your application at that point. How you actually...
That's creating an encrypted SQL database?
Right. So you can generate, PD, you can generate, pass it around. You can encrypt it when you receive it, not actually encrypt it before. I guess the point is if you're taking stuff out of that database, maybe the wearable says, hey, I'm curious about this, and then the handheld sends that data back, or the same handheld, gets it, persists it, maybe something, so on and so forth. But you might shuttle that data back and forth, or you need to encrypt it everywhere. Or you make a change in one place and you have to replicate that across all the different devices. So, I guess that's what that's kind of going basically. So, you know, if you have a secure container, that's great, because it's on one device, you know. You have to have that container in multiple places. Well, you know, you duplicate those efforts, you know, do you use the same encryption stuff across the board? You know, because obviously you have, you know, multiple points of exposure to actually, you know, get those keys and pose the data. So, you know, you basically take the problem from one place and you put it in a couple different ones. So, really, that was just intended to kind of show you, like, that's easy. Well, I mean, this is not the greatest way to do it, but you see where I'm going with that?
Well, in the context of Android, what is a secure container?
So basically, you know, look at like the third-party ones. So like Good has one, and it's just basically, you know, a place to store stuff. It's encrypted, and it's just basically, yeah, it's a nice, safe place to put your data. Is the, I guess, best way to explain that.
Okay, so it's encrypted, but where does the key come from? I'm just not familiar with these.
Yeah, I mean, you still have to store, you know, so it depends, yeah, so, I mean, some of those could potentially be asymmetric, you know, maybe it pulls it down at the time of. There's different ways of seeing that kind of stuff implemented, but yeah, in the end, you do have to store it somewhere, definitely, so.
Okay.
Yeah, I mean, yeah, you can't get around, like, Samsung Knox, for example, I don't know if anybody saw the, there was an interesting article, so basically they store, like, the PIN, like, in plain text on the Knox. You know, Samsung Knox is like, you know, NSA approved, like, you know, super duper secure, and in the end, they still store basically like the PIN on their plain text. So, yeah, I mean, Samsung screwed up. So, any other questions? I'm just about my end of time here.
All right, if there aren't any other questions, please give a big hand for Jack.